So far we have learned about some of the basic concepts in Prolog. Now we'll look at some other concepts. Lists. Lists are the data structure that can be found in Prolog. This is just like a data array that can use in procedural paradigm. List consists of atoms or a sequence of atoms. We'll take a simple list and identify the content. As you can see, it's made up of a sequence of characters or sequence of words or phrases. A single component in a list called atom, and we can find a sequence of atom in a list. I think now you have a basic idea about list. Now we'll move into the list manipulation. List manipulation plays a major role in Prolog. Any list consists of two parts, that's head and a tail. Now if you want to pick up the first element of from this given list, what you want to do is you have to pass this list to a parameter as a parameter to a function where the head will contain the first element of the list, that's Mexico, and the tail will contain the rest of the elements that are in the list, that's New York, Washington and California. And when you want to access the other elements, you can pass it to the same function again and again to get the atom you want. This method is called recursion. We can see more about that in a different chapter. So those are the basics of list manipulation. With the previous chapter, I think you have a basic idea about what is recursion. We will now see in advance about recursion. Because of the logical program does not have maintained states, memory access or variable declaration, it uses a simple method to do the iteration, that is recursion. The basic behind this is self-call of the same function again and again. Now we'll take a simple example to understand this. When you want to take the factorial value of the given number, this will be a better solution to a problem. Using a recursion method will be a better solution. Now we have a factorial function. The output will be stored in the variable called x, and output will be calculated like this. And when we are creating a function, we have to know the base condition where the function ends the operation and return the back. And if you take the function, the base case of this function is 0, and if the value is 0, it should return 1. So the function will be written like this: factorial nx, that's factorial ym, and we are taking the y, that's always one deducted value from the n, and the final outcome x is the multiplication of the n and the m, where m is the intermediate results that is stored in a variable. And now we'll see how this function passes the value. Now we are going to elaborate what's going to happen in the previous example. In the main window we have two main functions, that's the n, that's we are passing value, and the intermediate result will be stored here, and the intermediate results will be the values that are 4, 3, 2 and 1. The multiplication of these value will be passed to the variable m. Now if you take the function, this function will be false when it reaches the base condition. Base condition is 0 and it will return 1. This will be coming from the backwards. First it will return from the here, and the value will be taken, and again it will come until it reaches the value for a m. Now I think you have a basic idea on recursion. Now we'll see what is resolution in Prolog. Resolution is an inference rule that allows inferred proposition to be computed from a given proposition. This will work as follows. Let's take these two clauses that can be resolved with one another if one contain a positive literal and other contain a corresponding negative literal with the same predicate symbol and the same number of arguments, and if the argument of the both literal can be unified with one another. Clause 1 contains the negative literal, that is QBC, and clause 2 contains that as a positive literal, that is QBC. And since the argument of the two literal can be unified, we can take the third clause, that's PA, is RBC. This process can be considered as the foundation of artificial intelligence. Thus, the program have the ability to resolve things on its own. Let's move into the unification. Unification is the process of using the resolution to match of a query against here of clauses in the logical program database. Finding the assignment of values to variables, that is make the goal identical to the head of